Okay. Let me go delete all the crap posts that this thing just automatically made for me. My bad, guys. It's just like... There. This should hopefully be good. I think it's just our wired internet just being crap here. We'll try it on Wi-Fi, which ironically should be more stable. Alright, so we have our drone.h. We should be able to get rid of all this stuff. Including the rings. We're going to rename the NVIGS to Drone Race. Make sure the stream is stable. Looks good. The chat didn't die, did it? No, I think it's okay. Category does not seem to be persistent. Lovely. Yeah, you're right. See, this is why I don't do it, because literally every time it does anything, I have to redo it, but we'll do that. Alright, whatever. It should hopefully be stable now. I'm pretty sure it's just that we have like jank Ethernet cables, like jank connections or jank something here. Whatever. I don't want to deal with it. It should be good. We'll just do it on Wi-Fi. Should be good enough. Okay, so we need this random ring function. I must have gotten rid of. Let me go grab it. Oh yeah, star the puffer lib. Like, start the puffer if you haven't. It helps us out a lot. It's free. I say we just put this into the drone lib, right? Oh, that actually already works. Cool. So yeah, so that wasn't that hard, right? I don't know if it's actually using the drone. Yeah, it's probably not using the drone though. It's just using these like random functions. So let's fix that. Yeah, you see this has like position, previous position. So what we're gonna do is we'll just do drone, drone like this. And drone does have position, right? Let's just check. So this has position. What's it need previous position for? Oh, it does need previous position now. Okay, so we'll just do vec3 previous position. Holy, yeah, there's gonna have to be a lot of substitutions. What's gonna happen though eventually, right? We're gonna get to a point where these look similar enough that we can just make it like either one env with configs or something. We can kind of just train on a ton of different tasks. Like the RL is kind of good enough that if we just give it a lot of tasks for drones, as long as it's fast and they're reasonably posed, it should just work. The RL side's very good at this point. It's mostly just about getting the sims to be built better and faster. We're planning on improving the physics. Awesome. So my plan, Sam, you can tell me if you think that this makes sense here. So we're gonna want to do a lot of different stuff with these drones to test them out. And we're gonna have to do like the ring racing task. We'll do swarming stuff. We'll do like obstacle avoidance. We can do tons of stuff. I'm gonna try to. I don't want to modularize stuff a whole bunch to the point that it becomes heavy. All I want to do is just take like the drone physics and all the parts about the drone control and then separate those from the task specifics. So we can just have a couple hundred line like drone.h with all the physics or whatever, and then we can just include that in whatever other sims we want to build around it, right? Whatever other task, whatever other sims. And maybe eventually we will converge on like one set of observations, or maybe we'll find other ways to unify things, but I'm not going to worry about that too much initially. I just want to make sure that we have one spot for at least like the physics and such. And I think that'll help us out quite a bit, because then I'm going to start introducing randomized versions of these, right? Or like I'm going to add randomization parameters. So you can just say, all right, whenever the drone moves, right, let's just screw with the physics by a small delta. And the idea is that if it can behave under all sorts of different small perturbations, it should just behave well generally. We'll also do the same type of stuff for like the drone size and so on and so forth. And I'm going to try to do this without making it any heavier or any harder for you guys to use. That's the goal. So I'm running research side support. Perfectly reasonable. Something in Quatlib. Yeah, we're just not going to try to like worry about it too much initially though, right? Like, over modularizing is just the way that you break everything. I don't want to do that. I just want to have the physics separated cleanly because of the randomization work. Just so we're not like, copy pasting all the lines into the file and like having two different versions of physics. Delay largely unnecessary. I actually don't know about that. It depends on how good of a controller you have. Like, I think you still might need to do something with, if it's like 50 ms delay, that might be a lot, right? If you get like 10 ms delay, I think we should be good. I just don't know like with 50. Also, my mic is super loud. Hang on. Let's not clip the mic too much. There we go. Yeah, plus this is kind of chill. Today we kind of just get to like chill and improve drone code. Just invest a little bit into the core. Transmitter's really good, but we need to see. Delay is like slightly inconvenient, but it's not that bad. I think that the best thing we can do is in parallel, if you guys get the drone flying and you can like run commands on it, then and I can get the sim to be really robust, we should be pretty good. environments. Cool. Welcome to all the YouTube folks. The people who just got here, we're currently working on the, well, both of the drone environments. One of which is this swarm sim right here, and the other of which is a racing environment that looks like this. We're doing a little bit of work on just getting the code to be easier and cleaner across both of these. And then we're going to do some work on domain randomization that's going to make it a heck of a lot easier to make this work on a real drone. In fact, you know, one thing that I think is going to be really cool about this is if I do this correctly, it should work on like a ton of different types of drones. Like we probably, the best case scenario, right, is that we'll just be able to buy different drones and hook this up and not even really have to do any work specific to each drone. Are you planning to track the drone position? Track relative to the start position? Yeah, so for now, right, we're probably just going to do everything relative. So we'll just see if we can like get it to fly around in some patterns. We are going to have to do perception for the real hardware at some point, but like it's not going to be end-to-end RL division, right? It's probably just going to be some sort of basic state estimation, at least to start. Welcome, Barty. Welcome, Jason. It's worth spending some time cleaning this up because we're actually going to use this for quite a bit of stuff. And I don't want to I don't want this code to be a mess. It just causes us problems. To be fair, Finn and Sam submitted me very clean code. I kind of made a mess of it in the process of making it multi-agent. But like it should be very possible to keep it to make it multi-agent and just as simple as before, if not simpler. Oh, that's so funny. Ghost TTY renders. It renders these arrows as like the arrow character in the term. It's funny. Ghosty. Okay, so this now works again. Conveniently, we have the pre-trained model loaded into C, so I can know exactly if I break it. Right? As long as I don't modify ops, I shouldn't have to break it at all. Let's take a look through here. We still have 500 lines of stuff somehow. And a lot of this we should be able to... A lot of this we should be able to kind of just stick into the main thing. Let's do... If we just assume we make them env logic multi-agent, we assume we make it multi-agent by default. I think we should just assume we make it multi-agent by default, right? We'll separate out stuff like collision checking, right? Hi, I'm new. Are you writing an env? I'm editing an env. I'm definitely making changes to an env. Drone racing env and drone swarming env. both of these. Oh yeah, also for the new folks around here, we do have, there's like 25 plus pages of reinforcement learning intro material that will go live as soon as this hits 10K. So go ahead and follow this on X if you want RL content and you want that guide. Yeah, I think that if we just like, if we assume it's multi-agent, then basically almost all this code should just be directly usable, right? Pretty much the actual code here, this drone race code, is just going to be like the 100 lines or whatever it is to wire it together. We can probably get most of this code to be separated out cleanly. Take a little bit of work, but we can do it, and it's worth doing the work. Let's like look for env in here. We don't use the env until the out of bounds checks at all. So we do OOB check at the end. And all of this logic down to here just goes into a move function. So we can clamp the actions. Okay, and now this is move drone. The ring stuff is a bit more complicated. But this as is should work, right? Did I mess up? I forgot the comma. Okay, so this still works, yeah? This function is going into the drone lib. We can probably get the ring logic to be standalone if we try. It's just the fact that that's hard-coded right now, right? Oh yeah, this is just like jank, right? Yeah, this is just jank, the way this is written. Okay, so this is now, oops. Yeah, pause and normal, right? Okay, yeah, I didn't realize that this was done this way. That's better. Let's see if I broke anything in the process of doing that. No, not at all. Okay, so that's like, the checks are actually very simple. It was just really verbose because they didn't make a ring variable. So we can do valid dir, invalid dir. So we can just make like a check ring or whatever. Can I do float? I see. So all I have to do is I have to take more of this logic and put it in there. Okay. So like all this somehow goes like here. And then this, we'll make this a float. Okay. And return -1. And then what I'll do, I see what we're gonna do. So we'll here what we'll do is we'll do float reward check ring. Do ring start ring. Okay, and then like something like this. So we'll do if reward 0, 0 is equal to if the reward is less than this, if reward's greater than 0, we set the terminal, we add log like this. Okay? Something like this should be fine. Clarity. That's pretty clean. Redefined ring, skip this. Non-void function does not return a value. Return 0. And this still works. Didn't break anything. Now I think we know the routine here, right? This just goes into DroneLib now. We've got 300 lines. I'm fine with the DroneLib being a little longer if it's going to include all the objects, right? Because we'll probably put like collision obstacles in there. We can put like sphere collision obstacles, right? So it has to like route around an obstacle field. We can do lots of stuff. Heck, technically, right, we could do like, you know, like the asteroids game? We could do that with the drone. That'd be pretty cool. Actually, we should do that. Like actually have like asteroids thing, but with real drone physics. Be cool. Okay, what else is in here? Probably all this stuff about camera control. I mean, this is directly copy pasted, right? Just do this. It's literally the same thing. We might want to do like separate stuff later, right? But for now, we'll just put it into DroneLib. Oh, but we don't have the client defined, so we can't actually do that. Yeah, actually, that's a little less trivial. At least for now. I mean, we've already made this a heck of a lot easier, though. Let me just make the other file, like the drone swarm, work, and then, so we don't spend too long just refactoring right now, we'll start on a little randomization type stuff. I should have gotten a policy in here, but it's okay. So we do drone swarm. And where are the dynamics? Yeah, you see I have the exact same dynamics here. Float star. So idea here should be just do this. Move drone. Yeah, and then what I have to do is I have to copy. I have to be very careful with this actually. So this is what I'm going to do. Okay, so this still works. So now we have the movement function with all the physics. Cool. I'm going to do this. We'll do this for drone race even. So with the things to randomize here, right? We want to randomize quite a bit of this stuff. I'm trying to think what we want to randomize per episode versus what we want to randomize per step. I'm going to do a quick little brief introduction to I can do like a quick little introduction to domain randomization if folks are interested in that. So the paper to read for domain randomization, especially in control if you're interested, is this result. I was at OpenAI when this work was being done. I didn't interact a ton with the robotics team, except at lunch. But if you look at what this is, you see how they just have tons of different versions of this? You don't just randomize the color, you randomize like the physics, you randomize everything. And the idea is that you can't exactly simulate the real world, right? You can do your best to try to simulate the real world exactly, but you're going to fail. Now, what you might be able to do, right, is you might be able to make a noisy sim where like the robot learns to behave in enough different scenarios that it doesn't really have to exactly match the real world because it's going to just be robust enough anyways. This is a very, very effective technique. It's been used in tons and tons of different areas. Actually, they tell you right here, object dimensions, link masses, surface friction coefficients, damping coefficients, actuator force gain, joint limits, gravity vector. These are actually very big randomizations. Keep in mind, like, the RL wasn't as good back then, so they had to really crank this to make this thing work. And also, like, humanoid hands are not super easy either. It's like a pretty high degree of freedom problem. So actually, I'd say most of the problem of humanoids is in the hands, not the rest of the robot. There are more degrees of freedom in the hands than the rest of the robot for most models. Okay. So knowing that, I think we do a per episode randomization. It'll be easier, and I think it'll cover pretty much the whole use case. We will see if I'm correct on that, but I think it should cover just about the whole use case. Do you recommend reinforcement learning? Is that the original book or is that a new book? Is that like the original Sutton and Bardo book or is that a new one? Yeah, this is the original book. So it really depends, Jason. If you have a mathematically heavy background and a weak programming background, you might find that a decent way to learn. The thing is, it covers a ton of mathematical background, which is good, but at least the way that I've approached things, it's most of the math doesn't actually work. So it's going to give you the impression that reinforcement learning is like this very well theoretically justified, clean-cut field, and it's really not. Like, none of the math actually works. Where I've come from, I've found it way easier to just treat reinforcement learning as an almost purely empirical field, right? Like an almost purely empirical field. Just completely ignore the MDP formalism of everything. Yeah, we still write some formulas, but they're models more than anything else, and they're like really bad models at the best of times. If you look at my quick start guide, you're going to see the types of things that I generally recommend to newcomers, which are actually a lot more accessible mathematically and are going to get you writing a lot more code on things that work very quickly. So if you check my quick start guide, that's a good resource. You can decide from there what you think on the more formal material. Also, probably within the next day or two, as soon as this hits 10K, as soon as this number hits 10K, I'm releasing my own guide, which is like 25 pages of material on programming, ML engineering, and then mostly the majority of the material is on how to learn reinforcement learning. Like a very step-by-step guide on read this, implement this, so on and so forth. I didn't miss any meetings today, I hope, right? No. It's funny. Hey, Tyler. Welcome. We are doing drone things today. Oh yeah, I forget who it was, but there's a second. We've got like a second physicist around who's been watching some of the streams. That was a cool thing. I say we just make all these things properties of the drone. Right? We just make all these things properties of the drone. We're not bothered as long as it works. Well, I'm trying to make it also very simple as well. We're going to make these properties of the drone. We'll do like an init drone thing. Okay. And then we'll just do float domain randomization. And you know what we can even do? I'll tell you what. No, I don't want to leave these constants in as the problem. Keep the unit comments. Oh yeah, oops, my bad. Okay, do we have like rand? Yeah, rand f. Float RNG equals -d. It's gonna be I should probably do like base instead of doing it this way. Yeah, let's do it this way. Hang on. That way we don't drive you guys totally crazy. I just need to make sure I change the names of these because otherwise, like, there's something is still gonna be using the originals. Okay, so that domain randomizes the entire drone. Oops. DT can stay the same. I think DT is going to need to get randomized, but DT might even need to get randomized every step, honestly. Because you're not going to have precise control intervals. But we're going to just like start like this. I mean, once we get this hooked up correctly, it's actually running domain randomization experiments can be made very, very easy if you know how to do it correctly. It's very hard if you don't. Yeah, so here we have these norms. This should not break the policy though. At least it won't break it when we set dr to 0. That's the goal. Like the goal is that the policy shouldn't break until we crank dr up. It's RPM. Well, that's a bit much, huh? That's funny. All right, let's do 0.0f. Okay, so this is, look, with no domain randomization, it works perfectly. I suspect I just did it kind of stupidly. Yeah, see, this is plus RNG. This should be 1.0f minus dr and 1.0f plus dr, and then it should be times RNG. I wanted to do 10% randomization, not 0.1 flat randomization. Okay. Uh-oh. My computer just froze. That's weird.